Welcome to today's explainer. Look, if you're managing enterprise technology right now, you're standing on the precipice of a massive, industry-wide earthquake. Major software as a service vendors are forcing sweeping architectural changes down onto their customers, and they're doing it incredibly fast. We're talking about mandatory, fundamental shifts that nobody asked for, yet every enterprise is going to have to pay the price for. Today, we're doing a deep dive into the 2026 SaaS migration wave. We're going to unpack exactly why your SaaS providers are pulling the plug on legacy features, and more importantly, how you can defensively architect your systems so you never get caught footing the bill for a vendor's upgrade ever again. Just listen to this ticking clock for a second and look at how rapidly these deadlines are accelerating. By March of 2026, Atlassian is blocking new data center license purchases on their march toward a total 2029 end of life. In July and August of 2026, Salesforce is cutting over standard SMS channels and demanding a Microsoft Graph upgrade for Einstein activity capture. And then by October 2026, Microsoft begins the phased disablement of Exchange Web Services. If you fail to upgrade your authentication protocols in time for these deadlines, data capture stops entirely, automations break, your sales teams will be forced right back into manual data entry, which completely degrades your CRM completeness and totally blinds your pipeline visibility. The clock is ticking loudly, folks. All right, Section 1, the 2026 SaaS migration wave. Okay, let's dive into this. We really have to change our mindset from being victims of a vendor's roadmap to actually taking back architectural control. I absolutely love this quote from our source material because it perfectly hits the nail on the head. It says, "The standard industry advice treats a vendor feature retirement migration as an unavoidable weather event." Think about that. The usual playbook is just to, read the release notes, brace yourself, endure the storm, and dutifully follow whatever upgrade path the provider gives you. But that reactive posture, it masks a critical vulnerability in your business. The point here is that exposure to forced migrations is actually a controllable design choice. You don't have to just sit there and take the rain. You can build a roof. Moving right along to Section 2, the AI era architectural shift. So, why is the weather suddenly so rough out there? This incredible density of forced migrations happening in mid-2026 isn't just some strange coincidence where all your vendors decided to annoy you at the exact same time. It's a structural, industry-wide pivot. Just compare these two approaches. On one hand, we have legacy integration pathways. Things like browser-based JavaScript APIs used in Salesforce OpenCTI or those old all-or-nothing service accounts from Microsoft Exchange Web Services. Vendors are shedding these old protocols rapidly. Why? Well, because modern enterprise platforms are consolidating around AI-era architectures. Legacy web frameworks simply cannot feed the high-velocity, highly secure data streams required by modern generative AI agents in data clouds. Microsoft Graph provides granular OAuth 2.0 backed security. Salesforce Voice integrates natively with real-time omnichannel routing. Supporting the old, disparate pathways has just become an unacceptable burden for these vendors. Which brings us to Section 3, the true cost of upgrades. And this brilliantly illustrates a super painful reality. When a vendor decides they need to modernize their backend stack to support all this shiny new AI technology, they don't gracefully eat the cost of migrating your custom workflows. Oh no. They transfer the massive labor costs of that modernization directly onto you, their customer base. Take the Salesforce Einstein activity capture upgrade, for example. Legacy tools used to write calendar meetings as physical, queryable event records straight into the Salesforce database. But the new capture mechanism, it stores that event data on entirely separate cloud infrastructure and merely renders it visually on the timeline. So if you have custom dashboards, automated territory scoring, or record-triggered automations that are listening for those old event records, they all instantly break. A single backend change by the vendor literally blows up your entire custom setup. Let's actually quantify that pain for a second. If you've built your workflows directly onto the vendor's integration surface, your discovery costs are incredibly high. You have to hunt down every single custom script and flow tied to the dying API. Your development rework is high, demanding rewrites of multiple applications. And regression testing, it's extensive because every single end-user workflow has to be validated. But now consider the alternative, an owned integration layer. With middleware, your dependencies are centrally documented. The development rework is minimal because you're really just updating a single connector. And testing is contained purely to the data payload passing through that abstraction layer. The math makes it incredibly clear who pays the heaviest price for direct on-vendor integrations. Okay, Section 4, auditing your system exposure. Because, frankly, we can't defend what we haven't mapped. Before the next inevitable deprecation notice drops into your inbox, technology executives have got to proactively audit their environment to find out exactly where the blast radius is going to hit. You want to target these precise risk score variables. You need to look for legacy authentication protocols like EWS, because those carry immediate global disablement risks. You need to identify direct API connections. Where are your custom scripts talking directly to a vendor instead of passing through an internal gateway? Look out for exact database schema dependencies, just like we discussed with those event records. And finally, you have to score the workflow criticality. Ask yourself, if a vendor severs a pathway without warning, does it just annoy your staff, or does it completely halt your revenue generation? Mapping these dependencies reveals your hidden exposures right now, today. All right, Section 5, Building an Integration Layer. Now that we actually know where the risks are, we can implement the ultimate architectural fix. This is where we stop playing defense against the vendor's roadmap and start taking absolute control of our own. An owned integration layer is essentially a protective internal abstraction buffer. You build it using middleware services, standard RESTful APIs, and event-driven contracts. Its entire purpose is to isolate your core business logic from proprietary vendor APIs. This is the big architectural imperative. You don't necessarily abandon the SaaS platform for sure, but you absolutely must stop building load-bearing workflows directly on their retirable surfaces. Let's move to and see how this builds out a highly resilient system. In step 1, your third-party system, let's say it's a telephony provider, connects directly to your internal middleware, not to the SaaS vendor's UI. Then, in step 2, that middleware interfaces with your SaaS platform using standardized APIs. And then the magic happens in step 3. When the vendor inevitably deprecates their old API down the road, your core business logic doesn't even care. It remains totally untouched. You just go in and update that single middleware connector. You have successfully converted what used to be a multi-quarter, highly disruptive rewrite into a quick, predictable 2-week sprint. Of course, pulling this off takes some specialized engineering practices. A modern middleware stack looks like this. It's resilient, highly available infrastructure utilizing Kubernetes, Docker, and Postgres. Engineering teams deploy lightweight, containerized sidecar services that handle all external SaaS communications transparently in the background. Solutions like Baytech Consulting's Tailored Tech Advantage actually use rapid agile development methodologies to implement these components without disrupting your daily business operations at all. You get total control over your data routing, and you get it seamlessly. But hey, let's be pragmatic here. Building custom middleware incurs hosting and operational costs, so you have to use strict break-even logic. If you just have an isolated capability, like maybe a single non-critical SMS routing rule, the most mathematically sound choice is to just accept it and migrate in place. But if you are dealing with core business operations, complex, multi-stage routing across telephony, billing, or ERP systems, building that abstraction layer is absolutely essential. Otherwise, you're going to be paying for endless development rework every time the vendor changes their mind. And for end-of-life systems, like Atlassian Data Center, replatforming via sidecars lets you gradually move logic off the dying platform with virtually zero risk. Which leads us to our final part, Section 6, SaaS Contract Defense Strategies. Architectural defense is incredibly powerful, but to fully protect your enterprise, you need intelligent commercial defense too. And it starts with this single vital number, 24 to 36. Chief technology officers must enforce strict master service agreements that legally guarantee a 24 to 36 months of advanced written notice before a vendor is allowed to deprecate any public API or integration service. Standard contracts heavily favor the platform's ability to degrade services whenever they feel like it. You have to negotiate that baseline of operational protection into writing. And it doesn't stop at notice periods. You need to mandate migration support commitments. The vendor must provide full parity documentation so you actually understand what's changing under the hood. They need to provide dedicated engineering support hours to help you through the mess they created. And critically, they must provide access to parallel testing environments at no additional cost during that whole transition period. These clauses legally constrain the chaos and ensure the vendor actually shares the financial burden of their own feature retirements. The truth is, the aggressive retirement of legacy features is simply a permanent fixture of our technology landscape now. Relying completely on a vendor's proprietary roadmap is proving to be a fragile and incredibly expensive strategy. So I want to leave you with this question to reflect on regarding your own systems. What is your vendor retiring next, and who pays the price? By auditing your exposure, negotiating strong contracts, and architecting an owned integration layer, you stop paying that price. You reclaim your architectural autonomy. Thank you so much for joining me on this explainer. Start reviewing those architectures and take back control.